6.5 Inequalities in one triangle. Essential question: how are the sides related to the angles of a triangle? How are any two sides of a triangle related to the third side? Let's go to exploration 6.5 to do this comparison. I'm going to find the measures of all the angles, so I'm going to use my angle measuring tool. Now I'm going to measure all the sides. Now, right now I see that the largest angle, 70.56, is opposite the longest side, which is 5.1. I'm going to move the triangle in such a way to force angle A to be the largest. Now angle A is the largest at 96.84 degrees. Notice the side that's opposite it is 5, and 5 happens to be the longest side. So longest side and largest angle seem to be opposite each other. Let's take a look at the smallest angle. The smallest angle right now is 39.17 degrees, and it looks like it's opposite the shortest side, which is 3.18. Let me move the triangle around, and let's force angle C to be the largest angle. Now angle C is the largest angle. Notice that it's opposite the longest side. And again, look at the smallest angle, which happens to be 42.34, and it's opposite the shortest side, which is 4.08. Now that's what our theorem is going to tell us. It's called the triangle longer side theorem, and it says that if you have two sides and one side is longer than the other, then the longer side is opposite the larger angle, and the shorter side is opposite the smaller angle. The triangle larger angle theorem states that if you know two angles, then the larger angle is opposite the longer side, this is longer, and the smaller angle is opposite the shorter side, which is AB. This is going to help us solve a problem like this. We know that this length is, at the bottom edge, 32 feet. Left slope is 24 feet. Right slope is 26 feet. They're asking us to order the angles from smallest to largest. The shortest side, right here, is going to have the smallest angle opposite. So angle L. Our next side is 26, and it's opposite angle J. And then our largest angle will be angle K. Let's take a look at another problem in which we order the sides from shortest to longest. So we know that these two angles add up to 98 degrees, which means that our last angle, our third angle, is 82 degrees to force us to get 180 degrees. We want the shortest, which will be opposite the smallest angle. So that's going to be the shortest side. So we'll say DF. Our next angle will be 51, and it'll be opposite EF. And then our longest side will be DE. Okay, now it's your turn to try the problems. Go ahead and stop the screencast and then resume. And here are the answers. We want to now look at a group of 3 segments. Not all 3 segments form a triangle. You can see that the lengths 4, 2, and 5 do form a triangle, but the lengths 2, 2, and 5 do not. These short sides just don't reach enough to make a triangle. And these lengths 2, 3, and 5 also do not make a triangle. They end up meeting right here where we can't have a triangle. Let's go to exploration 6.5 and take a look at manipulating lengths of sides here. So here we have a triangle, and let's go ahead and find the lengths of all the sides. Now you can see that this base here is 8, and you can see that these two sides add up to more than 8. Now I'm going to take the triangle and I am going to kind of flatten it a little bit, and you can see that these two sides still add up to more than 8. I'll move 8 down here. And let's continue making it flatter. And you can see that these two still add up to more than 8, a little bit more than 8. But once B hits the side, then these two are 4, and this is 8, and we no longer have a triangle. Let's go ahead and take a look at that. You can see that these two add up to more than 8, and also you can see that these two add up more than this side, and that these two add up to more than 4. So any two sides have to add up to more than the third side, and that is the triangle inequality theorem. The sum of the lengths of any two sides is greater than the length of the third side. So let's go ahead and use this problem. We have a triangle that has a side of 14, and we have a side of 9, and the question is, what will be the third side? There are lots of possibilities here. Let's call this x. So what the triangle inequality theorem says is that 9 plus x has to be greater than 14, and then these two sides, x plus 14, have to be greater than 9, and then also 9 plus 14 has to be greater than x. So all three of these must be true. Let's go ahead and use our algebra to solve here. This will be greater than 5. And then this will be greater than negative 5. Now x has to be a positive value, so this will always be true. Always true. It doesn't help us find our answers though, but we know this is always true. And then this is going to be 23 is greater than x, or we can say x is less than 23. So we're going to put these two together, this one, and we're going to put it together in an inequality that looks like this. X has to be less than 23, and at the same time it has to be greater than 5. So x is greater than 5, but at the same time less than 23. Let's go ahead and test some values out. Like, let's test the value 6. So we can see 9 plus 6 is more than 14. These two are more than 9, and these two obviously are more than 6. I'm going to undo that, pick another number in between here. I'm going to pick 15. You can see these two add up to more than this, these two add up to more than this, and these two add up to more than this, so that works. Let's try 22, something close to the 23. Now these two add up to more than 14, these two add up to more than 9, and these two add up to more than 22. Now the number 23 does not work, and the reason the number 23 doesn't work is 9 plus 14 add up to 23, and these have to be more, otherwise it won't make a triangle. Okay, now it's your turn to try to figure this out. Go ahead and do 4 and 5, stop the screencast, and then resume once you have your answers. And here are the answers. For number 4, x is between 8 and 32. Any numbers there. And by the way, it could be a fraction, so you could say something like 8.5 or 10.3. It just has to be numbers between 8 and 32. And this is the end of the screencast.